A very good morning, student. Very good morning. Welcome to our physics class. The next important detailed question and answer from your 7th lesson, wave optics. The topic name is interference in thin film. Interference in thin film. Let us consider the film, thin film. This is the thin film. Yeah, this is the thin film, interference in thin film. Let us consider the thin film of transparent material of refractive index mu. Already we know the symbol of refractive index, that is called mu. Here, refractive index is not represented as small n, not to confuse with order of fringes n, and thickness small d. Here, thickness of the film is small d. A parallel beam of light is incident on the film at angle I. Here, this is the angle I shown in this figure. The wave is divided into two parts. At the point of incidence. One is the refracted, another one ray is reflected. So that means two parts. The wave is divided into two parts at the point of incidence as reflected and refracted lights. The refracted part which enter into the film again gets divided at the lower surface. So enter in the incident light enters in the film again gets divided. This is divided at lower surface into two parts. One is transmitted out of the film. This is transmitted out of the film, and the other is reflected back into the film. The reflected as well as the refracted. This is reflected, this is refracted. Reflected as well as the refracted parts are further formed multiple reflection. Here this is the multiple reflection takes place inside the film. B to C, then C to D, then D to E, and E to F is the multiple reflection takes place inside the film. The interference occurs in both the reflected and the transmitted light. So, interference occurs for transmitted light. The light transmitted may interfere to produce a resultant intensity. Let us consider the path difference between the two light transmitted B and D. Two waves moved together and remains in phase up to B. Where the splitting occurred, the extra path traveled by the wave transmitted. So extra path traveled by the wave is nothing but B to C, C to D. So BC plus CD is the extra path traveled. So the extra path traveled by the wave transmitted from D is path inside the film BC plus CD. BC plus CD. If we approximately the incident to be nearly normal, I is equal to 0. So nearly normal means I is equal to, that means normal line. This is the normal line. Maybe the incident line coincide with the normal means the angle is I is equal to 0. And the film of small thickness, the points B and D are very close. So point B and D may be very close. Now, are very close to each other. The extra distance traveled by the wave is approximately twice thickness of the film. That means BC plus CD means here twice times thickness of the film. That means A to B, that is one thickness D, and then B to C another one thickness. So D plus D is 2D. So BC plus CD is equal to 2D. As this extra path is transferred inside the medium of refractive index mu, the optical path difference is del is equal to 2 mu D. This is very important formula, children. Please note it down. Del, path difference, del is equal to 2 mu D for the thin film, interference in thin film. The condition for constructive interference in transmitted ray is 2 mu D is equal to n lambda. 2 mu d is equal to n lambda. Similarly, the condition for destructive interference in transmitted ray is 2 mu d is equal to 2n minus 1 lambda by 2. For reflected light, it is experimentally and theoretically proved that a wave while traveling in a rarer medium, here underline this word, rarer medium and getting reflected by a denser medium undergoes a phase changes of pi. This word is very important for your objective type question. It is experimentally and theoretically proved that the wave while traveling in a rarer medium and get reflected by denser medium undergoes a phase changes of pi, hence an additional path difference of lambda by 2 should be considered for reflected light. Let us consider the path difference between the light reflected by the upper surface here. This is reflected by the upper surface and refracted by the downward surface, that is the lower surface. So here divided into two parts, one is the reflected part, another one is the refracted path, reflected as well as the refracted. So upper surface at A and the other coming out C after passing through the film. Additional path traveled by the light coming out from the C is the path inside the film AB plus BC. Here AB plus BC. Now AB plus BC. For near normal incident and film of small thickness, this distance could be approximately AB plus BC is equal to 2D. So the formula del is equal to 2 mu d.